morning, everyone, and welcome to today's webinar, NGINX Plus R20 New Features and Highlights. The presenter for today's webinar will be Crilly, Director of Product Management, NGINX, now part of F5. If you have questions throughout the webinar, please enter them in the chat at the bottom of your screen. A recording of this webinar will be available after the event. I will now hand you over to your host, Liam.
Thank you, Anya. Good morning, everyone. Okay, this webinar is for the most recent release of NGINX Plus. That's R20. It came out just at the beginning of December last year, but with all the holidays, we're only getting to talk to you about it now. So let's dive in. So firstly, just to level set on what we're talking about today and how that fits in the overall NGINX product portfolio. We're talking about NGINX Plus, right? So this is at the bottom left of this diagram. This is our commercial offering based on the extremely popular NGINX open source project, where it's used for all sorts of use cases from API gateway to load balancer, web server, content cache, extended with modules such as web application firewalls, and generally, runs a good chunk of the internet. So that's sitting there. That's the data plane. We have another data plane product called NGINX Unit. That is an application server. So rather than running the HTTP traffic or application network traffic between the client and the backend, NGINX Unit is actually the piece of software that runs the application code itself, right? So you can think of it, if you're familiar with Python, it might be a unicorn. With Ruby on Rails, it's GUnicorn. Java has a whole ton of application servers like Tomcat, and so it sits in that space and is designed to be configured dynamically through an API and optimized for modern application development. That's Unit. And then sitting on top of that, we have our control plane product called Controller, NGINX Controller, which provides a centralized management, configuration, monitoring interface for all of your NGINX Plus instances for common use cases. So we have abstracted level configurations and an API-driven interface that allows NGINX Plus to be easily, conveniently managed at scale as a load balancer, as an API gateway, as part of a full API management platform, and coming later this year also as a service mesh. So that's the family. Let's dive into NGINX itself. So, as I mentioned, NGINX has a ton of different use cases that people use it for. But in essence, it sits somewhere or in multiple places between clients sitting out on the internet and your web applications, APIs, web servers within your application delivery environment. And as that most popular use case that we come across is as a reverse proxy, or as a scaled out reverse proxy, commonly known as load balancer. So in this way, the client sees a single, consistent, reliable, and very well behaved server. That server is actually NGINX, and it then makes connections to the backends to actually deliver that traffic, which means it can make good choices about which backend system to select, provide multiple load balancing algorithms on there, and apply security rules as well. So we can do authentication, we can do rate limiting, connection limiting, a whole bunch of stuff, some of which we'll look at in more detail in this webinar, based around what's new in that area. NGINX Plus extends the NGINX open source project. It does so in a number of ways, really designed around enterprise mission critical use cases. So we extend the load balancing capabilities with additional algorithms, active health checks, session persistence. We extend web app and API gateway use cases with things like JWT authentication, OpenID Connect for single sign-on integration. And we extend the simple set of metrics that are available in NGINX open source with an entire API ecosystem which allows for well over 100 runtime metrics to be collected, not only about the health and activity of NGINX, but also about the health and activity of the backends that it's connecting to. So NGINX started, the idea started really way back in 2001. The first version was actually in 2004. Let me show you the timeline here. And it was the idea of one man, Igor Sisoyev. He was working at a Russian internet portal company. Today, you would that role would probably be something like a site reliability engineer. And at the time, the internet was going through like the first phase of its explosive growth. Webs, we were up to, we were knocking on for about 1 million web servers, something like that, and that wave of new traffic, new activity on the internet was causing problems for the standard web infrastructure of the day. And Igor took a different approach to solving that. He set out to solve what was known at the time as the C10K problem, C10K being 10,000 concurrent requests on a single server. And he did that by taking an event-based architectural approach to building NGINX, so that essentially at a technical level, what's happening is that NGINX goes through an event loop, and as every HTTP request or TCP connection comes in, it just gets added to the loop. The loop goes round and round, and as soon as a request is at a stage where it can be moved on to the next phase of processing, then it does. And if it's not ready yet, if we haven't read all the headers, if we don't have the body, if we haven't yet made a connection to the backend, we just keep going around the loop until that is ready. And that's proven to be a very effective, low resource utilization, high performance approach to scaling web traffic. So on top of that, to help sustain the open source project, NGINX Inc. was founded back in 2011, and the first release of NGINX Plus was released in 2013. Fast forward to the back end of last year in December, where we made our 20th release of NGINX Plus in what was a pretty big year for NGINX, given that we were also acquired by F5 Networks and also made other releases of our controller platform. So before we dig into the details on what's new in release 20, let's just go back a notch just to do a quick recap on NGINX Plus R19, because some of the things we'll see in the webinar with R20 extend or are related to some of the activity that we did with R19. So R19 had a big emphasis on monitoring. We extended the NGINX Plus API with a number of new metrics and the ability to collect metrics in a more flexible way. So one other benefit of NGINX Plus is that it comes with a simple web dashboard, which allows you to monitor metrics in real time. Those metrics are also available in a JSON format through our NGINX Plus API. And we also made that available to be exported in Prometheus format as well. So there's a great choice in the way that you can consume metrics through NGINX Plus. And we added the ability to collect metrics. And I mean things like how many bytes, how many errors, how many requests in total, that kind of thing can be collected now in a granular way as you would like. So if you want to collect metrics on one particular URI, then you can do just that. If you want to collect metrics if a certain cookie is presented, you can collect metrics based on presentation of that particular cookie or any other parameter of the request. So a huge amount of flexibility on counters around certain parts, areas, or entire web applications. We added additional monitoring also for a DNS lookup activity. So NGINX Plus is acting as a DNS client and asking the DNS server to say return the list of IP addresses for a particular service. We can also keep a track on any errors that we might get from that DNS resolver. So that's a great way of troubleshooting. On the traffic management side, we introduced a dry run mode for rate limiting. And this is an area which is quite difficult to configure. If you want to make sure that individual clients aren't taking more than their fair share or protect against bots that might be running very quickly, then rate limiting is a great feature to have, but it can be kind of tricky to configure exactly what the right limit is. So we introduced dry run mode, so you can configure a rate limit, add the dry run mode, and you can either log or use the API to see would these requests have been limited against this configuration, so that you can fine-tune the correct rate limits without risking interrupting or unnecessarily degrading user experience. Okay, we also extended the key value store. We'll talk about that in a little while as well, so that you can put IP ranges using cider notation like /24, that kind of thing, into the key value store so that we can do a match against an IP address within a range, and then provide some configuration, very flexible configuration as to what you want to do with that. So the key value store is a great way of configuring NGINX in a dynamic way through the NGINX Plus API. Okay, so let's dig into R20 in more detail. So this is at a high level, and we'll try and go through each of these with configuration examples, and I've got a couple of demos lined up as well, fingers crossed for those. So the first thing we've done is that we've taken the improvements that we provided for rate limiting in the last release, and we've applied them also to connection limiting. So we have API activity, so we can track and count requests that exceeded a rate limit, and then we also have the same for connection limiting. I'll explain more in a moment. The key value store has had another extension. So as well as providing literal matches and network range matches, as I was just describing, we can now match on a prefix string. And that's very useful for matching against URIs and paths, for example. I talked about NGINX doing DNS lookups, and that's often used to integrate with service discovery systems. So they have a service registry which provides a name to IP lookup service. So you give it, say, I want to proxy connections to this service, and that service might be delivered by a dozen or so different hosts, different IP addresses. NGINX can continually check against that list of IP addresses by repeating DNS lookups. And now we're able to put that into individual upstream groups rather than have to have a global single external DNS registry. We've done some more with PROXY Protocol. We'll touch on that, and some additional hardening around our HTTP2 implementation. Let's get into the features in more detail. So rate limiting, and there are multiple types of limits that you can configure inside NGINX, and it's worth just spending a moment to differentiate on those. Usually when we talk about rate limiting, we mean request rates limiting. So either an individual client, a web browser, or an API client, and each HTTP request that it makes is a request, and we can control how many of those can happen in a fixed amount of time. So that's rate limiting, and it's configured through the limit rec module. So you see in this sample on the right, the very first line talks about limit rec zone, which is where we're going to track all requests. So what happens with rate limiting is that we can configure 4 or 5 different behaviors that we want to express for excess requests. So let's just look at this configuration here, right at the top. And let me just draw on a page so we can see what we're doing. Let's do that. Pen, red, yes, pen. Okay, so right at the top here, we've got limit rec zone. And this is saying that I'm going to key a rate limit against the request URI. So this is for every unique request, I'm going to apply a rate limit of 1 request a second. So that means in a slightly unusual configuration, I'm only going to allow 1 request per second to any specific URI on my application or my website. It might be more common to limit this by the IP address of a client or some sort of session ID or authentication token, but that's what this configuration is doing. We're then going to have a very simple log format followed by a map. So a map block is a very useful thing. It allows us to take in the limit rec status. So that's the disposition of what the rate limiting decision was. And it's quite simple. The rate limiting decision could be, I passed the request, no problems. I delayed the request because it was in excess, or I rejected the request because it was in excess. And whether I delay or reject depends on my configuration. So here I'm generating an output variable called in excess. I should have had a photo of Michael Hutchins on this page. The default is 1, so I assume that I have requests in excess, and if I pass the request, it's a 0. So you're going to use that later. And actually, it's when I'm in this particular configuration here, in this location, that I'm applying a limit rec policy. So limit rec zone is just collecting and counting requests coming in, and limit rec itself is doing the enforcement. And in this configuration, we allow a burst of 5, and after that, we're going to not delay requests. And if I don't delay them, it means I'm going to reject them. So we're allowing clients to burst. We're allowing up to 5 requests for a particular rate limit, and after that, if it's more than 1 per second, we're going to throw them away. And we've got rate limiting dry run turned on, so we can see if this is going to be a good idea or not. And then if I am in excess, I'm applying the if parameter to the access log, so that I actually want to collect all my excess requests in a different block file. I can also use the API endpoint, and this is exclusive to NGINX Plus. Everything else on this page applies to NGINX open source, and this API endpoint will then give me counters for the number of requests that were passed, rejected, delayed, or were rejected or delayed through a dry run configuration. So we differentiate on that as well. So that's rate limiting and logging. We have the key here is that there's a new variable called limit rec status, and that allows us to do a whole bunch of interesting things. Next up, connection metrics and logging. So what we've done here is connection limiting, as opposed to request rate limiting, is how many simultaneous connections a client can have open to the server at once. Typically, this is done at a network level, and in this configuration, we are limiting connections by the remote address of the client. Later on, in our location, we limit, we apply the limit con directive with a limit of this, in this case, 10 connections per remote IP address. And we've got dry run turned on so we can see what's happening. So what this configuration is doing is using the limit con status variable so that if we get a reject because of the dry run, then we're going to apply a bandwidth limit and slow down clients that are opening too many connections by giving them a really slow bandwidth limit on their excess requests. So we can use the dry run mode not just as a binary pass or fail configuration. This shows that we can actually allow the requests but slow them down. And it might be a neat way of throttling an API client that's going a bit too busy. So we've got the same essential configuration, behavior, visibility, logging variables, and API endpoints as we have for rate limiting, now also in connection limiting. So these two things work exactly the same way. And to help show those two things in action, let's try a demo. So firstly, let me show you the configuration that we're going to use. And I have that in VS Code. So here's my limits.conf, and I've just got a local Docker container running on my laptop here to show you this. Some of this configuration is what we just saw on the screen. We've got this simple log format, and we've also got some limiting configuration. So the first one of those is a limit rec for request rate limiting against the IP address here, and we're allowing a rate limit of 15 requests a second. And should we exceed that, we'll be using the 49 too many requests status code. And then I've got a second limit around connection limiting. So in this, I'm limiting against the same key, so the remote address of the client, and we'll see what the limits are down here. So here's the map we had before to see if I am in excess, and I'm going to listen on port 901, and here's my configuration. So I've got the dry run turned on for both, I think. Yep, so limit rec dry run and limit con dry run are both on. Limit connections is by 1 connection per IP, and limit on the request rate is by 15 requests a second. And if I exceed these things, then I'm going to have these JSON errors pop up. So first of all, let me just see if this is working. So I've also got the API available. So I'm going to call the API, which I've got on port 8080, type it, API 6. Okay, it's here and conveniently tells me what my options are. So let's go to HTTP, and I've got endpoints for limit cons and limit recs. So let's just make sure these are empty. There we go. So I've got my IP zone and all zeros because this is super fresh. And if I go to cons, I have the same. So I've got counters here for requests that were delayed, passed, rejected, and the same for their dry run counterpart. So just going back to the configuration, what's happening is that we're going to test these limits, and if everything's good, we're then going to pass it to a backend, which just gives me a simple web page. But as this requires some level of concurrency, I'm going to try and generate 10 little Safari browser windows if they lay themselves out. Oh, we've got 11. Okay, so here we are. They're hitting and refreshing every second, and you can see the timestamp increments and the colors change, so you can see when they have updated. So that's all fine. Nothing is being limited or rejected, and that's because both connection limiting and rate limiting are in dry run mode. And to test if that's working, we should be able to go back and look at these counters again. So let's look at the connection limiting. Right, I passed 275, and I would have rejected 57 of the requests so far by connection. And if I look at it by request rate, similar, I've passed a good number, and I would have delayed this number, and I would have rejected this number. So we actually have a two-stage rate limit in effect in my configuration, because I allow a burst of 2 above my 15 a second, and one of those will be delayed, and after that they'll be rejected. So it's quite a complex configuration here. Let us actually comment out both of these dry runs. Okay, dry run on. I could turn it off and just comment it out and save. Now if I reload the configuration, put alias for that, 20 demo, we should see that some of them start to get errors. There we go. So we've got too many requests. Hit on this guy. This guy over here had too many connections. Too many requests, too many requests, too many requests. So we have a mix, and now we've settled down to 1, 2, 3, 4, 5, 6 requests a second are going through. quite happily. So it all depends on how, whether they all decide to refresh at the same time or not, as to what actually happens here. So we've got a mix of both connection limiting and request rate limiting. And if I go back to my terminal window, check the endpoints again, I have actually rejected 4, actually delayed 6, and on the connection side, I had 2 requests were rejected because they were, I had more than one open connection from my localized IP. And let me just shut that down before it takes over my computer. All right. Next, key value store. So the key value store with NGINX Plus is an in-memory key value store which is configured through the NGINX Plus API. And it's very useful, therefore, for containing dynamic configuration. If you're familiar with map block configuration, it's very similar. You have an input key and you have an output variable, and it's essentially a nice, quick, efficient lookup table. So we can use it, for example, for putting a list of IP addresses that we want to put in a black list or a white list. We can use it for putting in IP address ranges that we want maybe to apply some different configuration to. Maybe it's a different authentication policy, a different bandwidth policy, that kind of thing. In this example, we have the key value zone configured, and this time there's a new parameter where the type is prefix. So when a key applied to the key value store, we match on anything that starts with the same set of characters. And what we're doing here is that we are generating, based on a URI with a prefix match, and cache control directive. So I can put in here into the key value store, maybe /images might have a cache control directive of something that expires or should be cached for 24 hours, and something that's in the /admin area or anything below /admin should have a no cache directive going there. It means that we can play with these things through the NGINX Plus API. So let me show, I think a demo is probably going to be more useful than more words on this subject. So let's try the second demo here. And it's a slightly different configuration. Let me bring up the configuration for the key val. And this is a ridiculously small and simple configuration. We have a key val zone called slow paths, which matches on a prefix, and we're going to match on URI path prefixes. So the key val will take in the URI that was requested and return the speed at which that URI should be delivered. All right, so that's why we're calling it slow paths. Listen put on a 2, and basically we're just going to deliver some HTML and web pages out of this directory. And then we apply the limit rate directive, and limit rate, just to get all the limits in. So we've done limit rec, done limit con. This is limit rate. Limit rate is a limit of bytes per second. So it's a bandwidth limit. And so the speed variable is derived from the key value store. So we've got to send in the URI, we're going to match on a prefix, we're going to get back the bandwidth that should be applied to this particular URI, and then we're going to control the response based on that. Let's see what happens on port 902. Let's jump to my web browser. I've got the dashboard running, so I can see that I've got key val demo, and my limits demo has had 402 requests we managed to successfully pass through, some 400s and some 500s along the way. Let's go to 901 and 902. Here we are. This is my key val prefix bandwidth demo. So let's just reload that a couple of times. There's no constraints here and reloading it quite happily. And let me just give you a peek at the horrible, no, I can't see it. HTML source, never mind. This is a simple web page with reference to one image, and that image is in the /images directory. Actually, let me do it in the spec. There we go. Bring that up. There we are. So the image is coming from /images. Okay, and what we're going to do now is let's look at the key vals endpoint. I've got the slow paths zone, and it's empty. So let's send something in there. So if we say that /images should have a bandwidth limit of 500 bytes per second, that's done. We got a 201 created. Let's just go and look at it again to be sure. There it is. So /images gets a 500. Go back to my web browser and put the network on and reload this page. And it's still loading at 500 bytes per second. Maybe I should have gone a little bit faster than that. There's the next chunk. As you can see, we've really slowed down the bandwidth to that. Is it going to finish loading? Yeah, it is. Okay, so finally finished. So what I can do, because this is an API configured, and I can just patch that, and let's make it 1500, so it's not quite as nasty. Go back, reload again. And it's a bit quicker. And so you can see how you might want to use this kind of thing to dynamically change the configuration for particular parts of your website or application. Maybe there's downloads area or particularly large raw images. You want to make sure that those parts of the site or the app don't consume all the available bandwidth for the more interactive and responsive parts of the site. You could also use this as a dynamic routing table. So you could put in a number of paths and then specify the upstream group where those paths should be sent. So there's a whole ton of stuff and great use cases that can be realized through the key value store now that it can match literal strings, IPs and network ranges, and also by prefix. Okay, next up is DNS resolvers per upstream group. So we have a directive called resolver, and previously this was configured at the top level HTTP context, so alongside upstreams, for example. And if you wanted to do a lookup for a particular service by name, you would have to use the same resolver in all cases if you wanted to do load balancing with it. Now we can put the resolver directive inside an upstream group. And that means that we can say, for example, here, our website upstream is resolved with this DNS server, and we can expand this host name here into all the IP addresses that deliver it. And for my mobile app, I can use a different set of DNS servers, one or more than one. I can have different timeout values depending on how responsive they are. And again, I can have a single server directive that expands to multiple IP addresses. So this is particularly useful when you're in a highly virtualized environment or containerized environments, and you've got different teams, maybe with their own service registries, and you want to make sure that each of them can specify and utilize the service registry for their particular application. This feature is entirely available in NGINX Plus only. And we've got a few other things too. So we did some, there were a number of security vulnerabilities across a number of vendors last year, around Q3 last year. We've done so. If you're using a version of NGINX Plus, or actually probably many web servers were affected, make sure that you're running at least NGINX Plus R18 patch 1 or newer. And then we've some additional smaller, less critical hardenings improvements we put into HTTP2 for this release. Yeah, we're seeing, as we see more and more adoption of HTTP2, where we're continuing to refine and build out as a high performance and robust solution as we can in NGINX. We extended also the PROXY Protocol implementation. So this is a way by which you can obtain the IP address, usually you should obtain the IP address of a client when there's some intermediate load balancer or proxy in between the client and NGINX. Commonly used in cloud environments where you might have a cloud load balancer sitting in front of an NGINX instance, and you still want to do things based on the IP address of the real client, not of the cloud load balancer. So PROXY Protocol solves for that. And we have variables already that tell us the client IP address and the client port. We have some new variables now which also tell you information about the server, that is the cloud load balancer or the other intermediate proxy between the client and your NGINX instance. And as ever, we continue to extend our capabilities in NJS. So NJS is the NGINX JavaScript module, allows you to extend your NGINX configurations with custom logic written in JavaScript. Obviously excellent for doing things like JSON manipulation and additional or customized authentication or access control logic. A couple of links here. You can search NJS on our blog for some instructions on how to start using it. If you are familiar with the Lua module, it provides a lot of the same sort of capabilities, of course, using the JavaScript language, and integrates in a very NGINX native way, and is one of the projects delivered by the NGINX core team. All right, so time for a summary. Let me just run these through and we'll have some time for some questions. So firstly, we improved and extended the monitoring and logging for both connection limiting and request rate limiting. So they now behave in very much the same way, configured in very much the same way, with variables for logging and metrics counters and a dry run mode to allow you to experiment and actually measure what's happening with those configurations in real time. The key value store has been extended with a prefix match type. So now that's ideal for matching on paths based on the URI that comes in, as well as previously matching on IP address ranges or just straight literal strings. DNS resolvers for upstream group we just mentioned. Additional PROXY Protocol variables for obtaining server information as well as client information. Some additional hardening around HTTP2 and additional JavaScript objects with NJS. So that's it for the slides. Just we've got a good 10 minutes we can use for taking questions. You see what we have on the list. Okay, a couple of questions here. Let's get this started. So a question from Fernando: how does it support request throttling? So request throttling is a term used by other products, and it's entirely related to the limit rec module and limit rec directives that we saw. So when I spoke about request rate limiting, I mentioned briefly that we have more than one way of handling excess requests. And one of those ways is analogous to throttling. So with throttling, what it usually means is if I've got a request rate of 10 requests per second and somebody sends me 10 requests a second, then I'm going to apply a half-second delay on each of those so that we actually only serve at 10 requests a second. That is implemented in NGINX by using the limit rec directive, and it is in fact the default behavior. So if you specify limit rec and you don't specify the excess behavior, it will delay requests until they can be satisfied by this defined rate limit, and that's throttling. So yes, we can do that. The other behavior is to reject. So if we say no delay, then we'll reject requests and send an error code of your choosing back to the client. And we also have a mode where we can allow a burst of requests. And that means that we can actually allow some overuse, then delay some requests, and then start rejecting the rest in a sort of two-stage mode. And if you look up rate limiting in our blog, there are some good examples on how to use those. So yeah, throttling is catered for. Next question I've got here is, why do we use slow path? What applications is it required? This really was just an example of how we can dynamically change NGINX behavior based on a path prefix. So this example was to slow down requests that are going to a particular path. I explained that bandwidth limiting against particularly large assets might be useful. So if you offer some software downloads or some very large images or documents, you might want to not allow those downloads to consume so much bandwidth that they exhaust what's available to the rest of the clients that are maybe just browsing around or doing high frequency navigation. There are of course many other use cases that you can use the key value store for. I mentioned dynamic routing use case is another one. Anything that you want to have a certain set of paths that should have some additional behavior configured against them would be a good use for the key value store with the prefix match. Okay, just seeing if we got any other questions coming through. Nothing right now. Oh yeah, okay, so one more question. And it's around, are the connection limits available in NGINX open source or just NGINX Plus? So just to clarify on that, the request limiting feature, the connection limiting feature, and the ability for those to have a dry run mode, and the variable that shows the status of the decision, that is all in NGINX open source. What NGINX Plus provides are the additional metrics in the NGINX Plus API that show you the counters, and so you can build real-time dashboards around excess requests and excess connections. Okay, don't see any more questions right now. So with that, thanks everyone for attending and for your time and for the questions that came in, and I look forward to doing the next one. Oh, and a question came in. Great, another question. Use cases for NJS. Can you use JS libraries like NPM modules to enrich the functions of each NJS function? That is the best question I think I've ever had, because the answer to it was actually published yesterday. So NJS can be used for all manner of use cases. If you there are some good examples on our blog, but to answer the question specifically, can you use other JS libraries? Yes, you can. NPM modules, yes, you can. So if you have, and here's an example might be, I want to do something special with gRPC. I want to do some protobuf parsing, or I want to do some XML parsing, and I know that there's an NPM module for that particular use case. There is a way that you can get those NPM modules and very simply convert them for use with NGINX JavaScript module. So JavaScript module can import and include other JavaScript code that you have available. And we just published yesterday a way of doing exactly that. Now, I don't have it to hand, but what I'll just say is if you go to nginx.org, on the right at the bottom, on the right-hand menu, there's NJS. And we added yesterday a document on how to do exactly that. So tell you what, if you can't find it, email me, liam@nginx.com, and I'll get the link to you. But otherwise, go searching on nginx.org for NJS, and you should come across some use cases and how to use NPM modules. All right, that was a long-winded answer, and enough for one more question to come in, so I'll make this the last one. Where can we get documentations and guide on WAF? So the NGINX WAF is based on mod security. If you go to nginx.com and under the products menu, there's an NGINX WAF area that has lots of information. Also, if you search our blog for WAF, you will see some kind of more real-world use cases for how to do that. And what we do with mod security module is that our engineering team provide a particular curated build of mod security. We hand select patches, we do a lot of performance testing, document those results, and we provide the WAF module as a dynamic module that can be installed on top of the NGINX Plus runtime. And we make that special build available to NGINX Plus subscribers for an additional cost. The mod security project itself, of course, is open source, and you can compile that in. But if you want something that's reliable and as fast as mod security you can go, then the NGINX WAF is a great solution. Okay, thanks for all the questions. I look forward to seeing you on the next webinar. Have a good day. Bye-bye.
Thank you, Liam. And thank you all for attending today's webinar and for all of the great questions. We hope that you found this webinar beneficial. As previously mentioned, a recorded version of this webinar will be available shortly. We look forward to having you on future webinars again soon.